Yeah. So here, what we'll get, guys? We got minus half minus. Here, one of the 5 will get cancelled. 9 by 10 minus 9 by 5. So as you can see here, we can group this minus 9 by 10, minus 9 by 10, minus 9 by 5. We can group this minus 9 by 5, 9 by 5, plus 9 by 5, plus minus 9 by 5. So minus, so we'll get 9 by 5, 6 plus 11 by 2 minus 1 by 2, which is 5. So 9 by 5 plus 5, which is 25 plus 9, 34 by 5 is our answer. Okay, so the property 3 is mainly used when we have these types of functions. Let us see one more example. Here we have step function. So we know that step function, how can we define the step function? We can write it as 0, we can write it as 1, we can write it as 2. So when we can write it as 0, if x belongs to 0 to 1. 1 when x belongs to 1 to 2. And 2 when x belongs to 2 to 3. That means we have to break this integral into 3 parts. From 0 to 1, from 1 to 2, and from 2 to 3. Now from 0 to 1, x will remain as it is. What will be step of x from 0 to 1? It will be 0 plus. What will be step of x from 1 to 2? It will be 1. So x into 1 dx plus x into 2 dx. So our answer will be integration of 1 to 2 x dx plus integration 2 to 3. 2 into x dx. Let us integrate. So we'll get x square by 2 from 1 to 2 plus x square from 2 to 3. That means 2 square 4 minus 1 by 2 plus 9 minus 4. So which is 3 by 2 plus 5. 13 by 2. This is my answer. So how this we can do it by using the property 4. Now this, both the properties are very important, and in many books, or you must also know that this is known as the king property. Right? What is the king property? It says that we can replace x by a plus b minus x. That is sum of upper limit plus lower limit without changing the value of the integral. Without changing the value of the integral. Now, property 6 is same. Just here we have 0 and here we have a instead of a and b. Right? So it remains the same. I can replace x by sum of upper limit plus lower limit minus x. Now, the main thing is not this property. The main thing is to know how to use this property. So that is best case example if we take an example. Let us try to understand this property by using the example. What I'm trying to say is, let's look at this example. Here, I can write it as 10x raised to the power 1 by 3. So if I write 10x as sin x upon cos x, so I'll get my integral I as integration 0 to pi by 2, 1 upon 1 plus sin x upon cos x. raised to the power 1 by 3. So if I take LCM, I'll get 0 to pi by 2 cos x raised to the power 1 by 3 upon sin x raised to the power 1 by 3 plus cos x raised to the power 1 by 3 dx. Let's mark it as equation 1. I hope you know what we are going to do. We are going to use the king property. King property says that I can replace x by sum of upper limit plus lower limit minus x without changing the value of the integral. That means I will remain I, everything will remain the same. Just in place of x, I need to put pi by 2 minus x raised to the power 1 by 3. Same in denominator, sine pi by 2 minus x raised to the power 1 by 3 plus cos pi by 2 minus x raised to the power 1 by 3. So here we know that cos pi by 2 minus x will be equals to sine x. So I get 0 to pi by 2 sine raised to the power 1 by 3 upon same cos raised to the power 1 by 3 plus sine raised to the power 1 by 3. Now usually after applying king, the two equations we add them 1 plus 2. So when we add them, LHS में I'll get 2i, RHS में I'll get integral 0 to pi by 2. As you can see, the denominators in both of them are same. That means no need to take LCM. In denominator is already cos raised to power 1 by 3 plus sine raised to power 1 by 3. The numerator when we add, I'll get cos raised to power 1 by 3 plus sine raised to power 1 by 3 dx. As you can see, this will get cancelled and we'll be left with 1. So I get 2i is equals to integration 0 to pi by 2. 1 dx. What is the integration of 1? It is x from 0 to pi by 2. So which is equals to pi by 2. But remember, this is the value of 2i. We want the value of I. That will be equals to pi by 4. This is my answer. I hope it is clear. Okay, guys. So after this, we have another property which is you must known as queen. Now, queen helps us to halve the limits or to halve the upper limit. As you can see here, from 2a, the limit reduces to a. That means it gets halved. Now, how to use this property? So first, we have to check the value of f of 2a minus x, 2a minus x and the value of f of x. If both of them are same, that means f of 2a minus x equals to f of x. Then our integration 0 to 2a will become, you can substitute it here, 2 times integration 0 to a f of x dx. The upper limit will get halved. And if these are not, if this is equal to minus f of x, then again substitute here. So we'll get integration 0 to 2a f of x dx equals to 0. So these are the results of queen. First, we need to check these two conditions and then apply. Now this same thing we will notice in the next property, which is the even odd property. But here it's quite simple. Here the range starts from minus a and ends at a. So it is from minus a to a. If it's from minus a to a, f of x is even function. What does this mean? This means that f of minus x will be equals to f of x, an odd function. Odd function means f of minus x will be equals to minus f of x. Right? So again here, first we need to check these two. Whether the function is an even function or a odd function. If the function is even function, then I can use this definition. And if the function is odd function, then I can simply put it as 0. Now, I have a very good example from the previous JEE main. Where all these properties, king, queen, and this even odd property, all these properties are used in the same question. So as you can see, JEE questions are very intuitive questions. Many properties can use the same question. Uh, yeah. Before that, I decided that I'll split the numerator. That means I'll write it as, I can multiply this x, I'll write it as x plus x sine x. And if I split, I'll get x upon 1 plus cos square plus integration minus pi to, okay, I'll put the integration afterwards, plus x sine x upon 1 plus cos square dx. Now these are two functions, that is this one and this one. Let's mark it as f of x and let's mark it as g of x. Now if you notice, f of minus x will be equal to minus x upon 1 plus cos square x, which will be equal to minus times f of x. That means this is an odd function, its value will be 0. And if we calculate g of minus x, it will be same x sine x upon 1 plus cos square, which is equal to f of x. That means this is a even function. That means I can write the integral now as 2 times integration 0 to pi by using the even odd property into x sine x upon 1 plus cos square x dx. Right, guys? Now, we use the even odd property. Now it's time to use the king property. So what does king says, guys? I can replace x by sum of upper limit plus lower limit minus x. So let's mark it as equation 1. The value of integral will not change, so I'll get 2 times integration 0 to pi minus x sine x, because sine pi minus x is sine x only. Usually after that we add 1 plus 2. After adding, what we'll get, guys? We'll get 2i is equals to 2 times integration 0 to pi. After adding, you can clearly see that the x and minus x will get cancelled. We'll be left with pi sin x upon. Cancel out this 2. Now we have used the king property. Now it's time to use queen. What does queen says? Queen says to check f of pi minus x and f of x. So let this function, let me mark it, be h of x. So what will be h of pi minus x? H of pi minus x will be equals to h of x. Please check if h of pi minus x equals to h of x. We can use queen and we can half the limits. That means the limit was 0 to pi. Now it becomes 0 to pi by 2. Sin x upon 1 plus cos square x. Now we can integrate by putting cos x equals to t. That means sin x dx will be equals to minus dt. So my limits will also change. So I will become 2 integration of cos 0 is 1, cos 90 is 0, 1 plus t square into minus dt. So I can split the limits. I can integrate it. It is tan inverse of t. Now minus है ना, so I can use a property number 2. So minus I can split the limits from 0 to 1. So it will be 2 tan inverse of 1, which is pi by 4 minus tan inverse of 0. My final answer is pi by 2. Got it? So J equations are very nice, very like logical. First we use the even odd property, then we use king, and then we use queen. Let's see the next theory. Next is definite integration by parts. So definite integration by parts is best understood, I think, with an example. So again, this is a J example. J means we can use a UV rule. So let this be the function u, let this be the function v. Or as you say, the first function and the second function. So how to integrate it? U, that means f double dash of 2x into integration of v, which is x square by 2. The limit will be applied all over here, right? I hope you know. Minus here in the integration sign, the limit will be applied, the outside integration sign. Now, Oh, I think, yeah, we took wrong U and V. Sorry, guys. You have to differentiate U and integrate V, guys. So U, integration of V. So F dash of 2x it will become. Minus derivative of U, which is 1, into integration of V, which is F dash of 2x dx. So we apply the upper limit minus lower limit simultaneously on both dash of coefficient of x. 2x upon 2, we already there is 2, we can use. Yeah, where were we? Yes. Now we'll use upper limit and lower limit on both simultaneously. So this will give 1 into f dash of 2 minus 0 upon 2 minus f of 2 minus f of 0 upon 4. Now we have all these values. Let us substitute it. So what we'll get? 5 upon 2 minus 3 minus 1 by 4. So we got 10 by 4. I took LCM minus 2 by 4, which is 8 by 4, which is 2. So our answer is 2. Right, guys? So this is the way how we use integration by parts. I hope you know it. This is just a revision. Next is the Leibniz rule. So Leibniz rule is basically derivative of integration. So here we take, like we integrate the function and then take the derivative. Instead, Leibniz said, let's do it directly. How to do it directly? So derivative of integration of a function is equals to, I to remember this. This is much easier to remember. That is f of upper limit into derivative of upper limit minus f of lower limit into derivative of lower limit. This is the function f of t. So what will be my answer, guys? My answer will be f of upper limit, which is root x, into derivative of root x, which is 1 upon 2 root x, minus f of lower limit, which is 1 by x, into derivative of 1 by x, which is minus 1 by x square. So what is f of root x? F of root x will be cos x upon 2 root x. This minus will become plus f of 1 by x. It will be cos square 1 by x upon x square. Simple. This is my answer. Got it? So it is better to always remember this formula. F of upper limit into derivative of upper limit minus f of lower limit into derivative of lower. I hope it is clear. Right, guys? Let's move on to the next, which is definition of periodic function. This is important. I hope you know all these formulas. What are the formulas, guys? These 4. Here, T is the period of f. Right? So the first formula says it is 0 to nt. Then we can bring n down, a to a plus nt. So basically, we can write it as n0 to t. A plus nt to b plus nt. Then we can simply write it as a to b. Please note that the function is remaining same everywhere. Just the limits are different. That's what I am trying to say. Pay attention to the limits. If it is 0 to nt, the n will come down. It will become 0 to t. If it is a to a plus nt, then it says that a will get cancelled and I'll get 0 to nt. which I can write it as n0 to t. If it is a plus nt to b plus nt, then nt will get cancelled. I'll write it as a to b. Right? Chalo. Let's look at the question to better understand it. Now, let's show that question. So I have to show this LHS is equals to this. Okay. So what I did, guys, I first splitted the limits from 0 to v mod of sin x plus integration of v to n pi plus v mod of sin x. Why I did that? Because it is given here that v belongs to 0 to pi. V belongs to 0 to pi. Now, if v belongs to 0 to pi, this means first and second quadrant. That means sine x will be positive. That means mod sine x will be equals to sine x. So I can write it here, integration 0 to v sine x dx, obviously, plus. Here you can see the property, this one. V to n pi plus v. Now, if such property comes, we can cancel out v and we can write it as 0 to n pi. Why? Because this pi is the period of mod sin x. And similarly, we can bring n downwards by property number 1. So it will become 0 to pi multiplied by n. Now 0 to pi is again in the first and second quadrant. That means mod of sin x will be equals to sin x. Let us integrate. The integration of sin x is minus cos x from 0 to v plus n into minus cos x from 0 to pi. This will give minus of cos v minus cos 0, which is 1 plus, I can write it as minus n cos pi. Cos pi is minus 1, cos 0 is 1. So what I got, guys, I got minus cos v plus 1 plus 2n. So I can group it. I can write 2n plus 1 minus cos v. This is the same thing that we needed on the right hand side, as you can see. This means it is hence proved. This is how we use the property of periodic functions. So this was it, guys. Thank you all. Please remember, in the next lecture, in this lecture we covered the theory part. In the next lecture, we'll be covering PYQs of January 2023. Please don't miss the next lecture. Till then, guys, bye-bye everyone. Take care. Bye-bye, guys. Thank you, guys. Bye-bye.